So today is Thursday, February 6th. There were a lot of people absent, especially fourth period after the tornado warning today. So I thought it might be helpful to offer a help video on the classwork from today. So I am going to go through all of the problems, but of course this is on Edpuzzle, so I'm not sharing this on Google Drive because if you're going to watch the video, you're going to watch the video. So I'm going to go through all of these. The first one is, this was page 8A, and okay, and of course this was the parent function. So this is f of x equals square root, not square root, I do that all the time, absolute value of x. So this is what the parent function looks like. Go ahead and put arrows at the end of these things because it doesn't, I did a screenshot from Desmos. So first thing you want to do is sketch this on your paper. You don't need to do the table, you don't need to do the XY table. It's not necessary because we have Desmos, so we don't need to do that. So what I start with is the easy stuff. I start with the vertex, and the vertex of the parent function, of course, is 0, 0. If you don't know what the vertex is, you can always take whatever is inside the absolute value symbol and set it equal to 0 and then solve for x. The line of symmetry is x equals 0. It's right here. It always matches this point right here. So x equals 0, that's where it cuts it in half, and the sides would be mirror images of each other. The slope in this case, the slope is your a value times any b value, the absolute value of a b value that would be right here. So if there is a coefficient of x, you want to take the absolute value of that and multiply it times a. Well, in this case, it's just 1. And you can look at that and see that the slope is 1 on the right side. Just look at the right side for the slope. Let's see, what else can we look at? The minimum value, there is a minimum value, and that is y equals 0. And you can just put 0 there, that's fine. Maximum, there isn't one. I want you to put a line or something there just indicating that you know that there is no maximum. The x-intercept, there's only one, and that's at 0, 0. The y-intercept, there's also only one at 0, 0 at the vertex. So let's go up to domain. Domain of absolute value functions are always the same. You can put this, all real numbers, or you can put negative infinity to positive infinity. The range starts at the bottom. It starts at 0. So we use a bracket for that, 0, and it goes to positive infinity. All right. We'll go ahead and do the interval where f of x is positive. That's where the y's are positive, which is above the x-axis. So this whole graph is above the x-axis, which means that the interval where it's positive is from negative infinity to positive infinity. Okay, the interval where the y's are negative is down here. There's no part of that graph that's down there. So we would say does not exist. You could put like a circle with a line through it if you wanted to. Does not exist is going to be the most common thing you'll see. Interval where f of x is increasing and decreasing. So we want to, this is the one where we trace from left to right. And so if we're tracing from left to right, this is decreasing, if you think about that roller coaster. And then this side is increasing. So looking at the decreasing side is coming from negative infinity. And we're always going to use x values here, not that it matters on this one because they're the same, but it's coming from negative infinity and it's going to 0. So decreasing is the one we just did. Negative infinity to 0. And then over here is increasing, so that is going from 0 to positive infinity. Okay. Oh, I put that in the wrong place. I'm sorry. 0, positive infinity. Let me get rid of that. Okay, end behavior. This particular chart always asks for the right end behavior first. I like to go left to right, but that's just me. So I'm going to do the left end behavior first. So look at the left side of the graph, which is over here. I want you just to look at the left arrow. That's all we really need to look at. That is going We need to determine whether it's pointing up or down and then left or right. So it's pointing up and it's pointing left. Up is a positive direction, left is a negative direction. This is always the y, the up and down is the y, and the left and right is the x. So the way we would state that, and remember this is the left side, is y approaches, use that arrow, y approaches positive infinity as x approaches negative infinity. Okay, and then on the right side, look at the right arrow. It is pointing up, or it's heading in the up direction and in the right direction. This is a positive direction, and this is also a positive direction. So this is y and this is x. So we would say y approaches positive infinity as x approaches positive infinity. All right, so that's that one. Next one is 8b. Make sure that this is the right one. This should be f of x equals negative, or the opposite of absolute value of x minus 2. Okay. To find the vertex, set what's in absolute value equal to 0, x minus 2 equals 0, so x equals 2. It's right there. I mean, we've already graphed it. So vertex is 2, 0. Line of symmetry, x equals 2. The slope is the absolute value of b times a. A is negative 1, so the slope is negative 1. The minimum, it doesn't have one. It has a maximum at y equals 0. The x-intercept is 2, 0. The y-intercept is down here at 0, negative 2. The domain is all real numbers. The range is, I've got to put my arrows. The range is negative infinity to 0. The interval where x is positive, it does not exist because the whole thing is below the x-axis. So you can just somehow let me know that you know it doesn't exist. The interval where f of x is negative, negative infinity to positive infinity. Increasing, negative infinity to 2. Decreasing, 2 to positive infinity. In behavior, I'm going to put the left in behavior. I'm going to do that one first. That's going to be y approaches negative infinity as x approaches negative infinity. Let me slide this up, see if this will write better. Sometimes it's just at the bottom of this tablet, it just won't work. In behavior, right, y approaches negative infinity as x approaches positive infinity. Okay. The next one is 8c, and the function was f of x equals absolute value of x minus 3 on the outside of absolute value. The vertex is at 0, negative 3. Line of symmetry, x equals 0. The slope is 1. Minimum, it has a minimum value at negative 3. Does not have a maximum. X-intercepts are negative 3, 0 and 3, 0. The y-intercept is at 0, negative 3. Domain is always the same. You can either do that or the negative infinity, positive infinity. The range is negative 3 to infinity. Interval where f of x is positive. Remember, we're using x values, so we need this one and this one, and well, actually, we don't even need that one. We only need the -3 and the +3. We're looking at negative infinity there and infinity there. So where it's positive, there's two intervals. There's this one from here to here, and there's from here to here. So negative infinity to -3. U symbol, or symbol, and then 3 to positive infinity. Interval where it's negative, again, it's here to here because it's one continuous interval there. So that's going to be -3 to 3. F of x is increasing, that's on this side, and it's going from 0, this time it's this x value, 0 to infinity. Where it's decreasing is over here on the left, and it goes from negative infinity to 0. Okay, in behavior, I'm going to do left first. So I'm looking at this arrow. It's going up and to the left. So that is y approaches positive infinity as x approaches negative infinity. I wonder if I can do my infinity like that. That might be better. Okay, in behavior right, y approaches positive infinity as x approaches positive infinity also. I neglected to mention that in your packet, 8C and 8D are backwards because I put the holes on the wrong side of the page. So you would have seen after B, you would have actually seen D, and then C was on the other side. So if you did D by mistake, just change this function equation to this. So just switch the equations and you'll be fine. Okay, so this is 8D, f of x equals 2, absolute value of x. And put your arrows there and go ahead and sketch it. The vertex is 0, 0. The only thing, this is the parent function. The slope is just changed to 2. Slope is 2. The line of symmetry is x equals 0. There is a minimum value at 0. There is no maximum. The x-intercept is 0, 0. The y-intercept is 0, 0. Domain, all real numbers. Range, 0 to infinity. F of x is positive, the whole thing, and negative does not exist. Line through a circle, however you want to do that, it's fine. F of x is increasing on the right side, and it goes from 0 to infinity. F of x is decreasing on the left side, goes from negative infinity to 0. In behavior, we'll just do them in order. In behavior right, look at this arrow. It's going up and to the right. That's positive, positive. I'm sorry, I said positive and put negative. Those are positive. And then the left side, look at this arrow. It's going up and to the left. That's positive, negative. I'm tired. It's been a long day. This is supposed to be a negative. There. 8E looks something like this. Okay. Vertex is at -1, 3. Line of symmetry slope is -2. Now, if there had been like a 3 in front of that x right there, we would have taken the absolute value of that and then multiplied it times that, and that would have been the slope, -6. So just remember, if there's a coefficient to that x, it's going to change the slope from this number to multiplying them together. Domain range is -infinity to 3. Let's go back over here. Minimum, there isn't one. Maximum is at y equals 3. X-intercepts, they are at -2.50 and 0.50. Now, don't put a u in between those because this is not an interval. This is two points. The y-intercept is at 0, 1. Save these two till last. They're the hardest ones on this one. Increasing from -infinity up to -1. Decreasing goes from -1 to positive infinity. All right, in behavior right. Let's look at this arrow. It's down and to the right. That's negative, positive. In behavior left, this arrow right here, down and to the left. That's negative, negative. Okay, now let's look at the intervals where it's positive and negative. So I'm only looking at this point and this point. I'm going to use negative infinity and positive infinity, but other than that, I'm only going to use these 2 points. So where f of x is positive, that's everything above the graph. The part of the x-axis that covers is only from here to here. Even though it goes up and back down, it still only covers these x values. So we would say that that interval is from -2.5 to 0.5 or 1/2. Okay. The interval where it's negative goes, let me get a different color, from here this way, because it's here down that way, but the x's that it covers are right there and right here. So there are 2 intervals. The first one comes from -infinity and stops at -2.5. And then the other one starts up at 0.5 and goes to positive infinity. All right, this is 8f. So we have sort of an absolute value function combined with a parabola, combined with a quadratic function. Okay, let's start at vertex turning points. So we have 2 points down here that, they would be called turning points. I don't think you could call them a vertex because it's not an angle. So one of the turning points is at 0, 0. Another one is at 4, 0. But if you look, there's another one because it is increasing and then it turns and starts decreasing. So we would call 2, 4 a turning point as well. There is a line of symmetry, and it's right here at x equals 2. So that does cut it in half, and the sides, the different sides are mirror images of each other. The slope, there is no slope on this one, and that's not even on your chart, so just draw a line there if you want to. Domain is still negative infinity to positive infinity, so it's still all real numbers. Range is from 0, that should be a bracket 0 to positive infinity. Okay, let's go over here. There is a minimum value, and that's at y equals 0. There's no maximum value. If this were just the parabola, the maximum would be right here. But there isn't one because it does go in the upward direction forever, so we'll draw a line there. The x-intercepts are 0, 0, and 4, 0. Y-intercept is at 0, 0 also. Okay, positive and negative, this is fairly simple because the whole thing is positive. So that's going to be our real numbers. And then negative does not exist because there's nothing that's below the x-axis. Increasing, this is interesting. I want to highlight this to show you. So as I go from left to right, this thing changes direction several times. And so if I go from left to right, right here, this is a decreasing interval. And then it turns and it starts increasing. And then it turns again and starts decreasing. And then it turns again and starts increasing. So let's look at the decreasing intervals. One of them is right here. So that's a decreasing interval. It does have that arrow on the end of it. And then this one's increasing. But this one right here would be decreasing again. So if I look at the other ones, they're both increasing intervals. So I have 2 decreasing intervals and 2 increasing intervals. So I just list them and put the symbol between them, and that's all I need to do. So this, and we're looking at x values on these. So let's look at the decreasing ones first. The green ones are the decreasing ones. This first one on the left is going from negative infinity to 0. So we'll make sure we put it down here. And then the second one is going from 2 to 4. All right, increasing are the teal ones. This one goes from 0 to 2. And the last one goes from 4 to infinity. Okay, in behavior on the right, up and to the right, that's plus, positive, positive. And on the left, I did that again, that should be a positive. And this one's positive. And this one's negative. So I just went ahead and did the last one for you so you can just check your answers or fill these in. The only thing I wanted to point out was on the end behavior, on the left side, y approaches this 2 line. It never actually touches it or crosses it. You can't tell here, but if you go on Desmos and you scroll over and then zoom in, you can see that it doesn't actually ever touch the 2. That's called a horizontal asymptote, and this is an exponential function, which is our next unit. So you can fill in your answers from this and let me know if you have any questions.